So in this video, we're going to look at finding max and mins when we have an interval so that we have endpoints. So again, we're going to always use the first derivative test if we have an interval because we have endpoints where it starts and stops. And endpoints are always either max or mins. So if I want to find the extrema, we do the same thing. We take the first derivative. So we get 6x squared plus 3 times 2 is 6, and then x, or we subtract 1 from the exponent, minus 36, and then the derivative of 2 is 0. And then we set that equal to 0 to find our critical values. Okay, now this one we will have to factor. So the first thing is always look for a GCF. There is a number that goes into 6, 6, and 36, which is 6. So I'm going to divide each of these by 6 when I factor it out. And then I'm going to factor the x squared plus x minus 6. So when we do that, we're thinking about what multiplies to negative 6 and adds up to a positive 1. Okay, so multiplies to negative 6. It would either be 3 and 2 or 6 and 1. But if you do 6 and 1, you're going to get 5 when you add them together because 1 has to be positive, 1 has to be negative. So that's not going to work. So you would have to do 3 and 2. And if I want to get a positive 1, I need the smaller number to be negative. So it'd be 3 and negative 2, which is 1. So this would factor to x plus 3 and x minus 2. And then we set each factor equal to 0. Now, 6 is a constant. It doesn't have a variable. So there's nothing to do with that. Okay, you could divide both sides by 6 and you would get the same thing. So you only set the factors that have a variable in them equal to 0 because we're trying to figure out where this equals 0. And if we solve this, we'd get x equals negative 3 and x equals 2. So if you plug in negative 3 to this, or 2, you get 0. So those are my two critical numbers. And so when we do our first derivative test, what we do is we draw our number line and then we put our endpoints on. So I'm going to put negative 10 and 3. And if one of these didn't fall in that interval, we would just ignore it and we wouldn't put it at all. But they both do fall in the interval. Okay, so we have 2, which would be closer to here, and that derivative is negative, or sorry, 0. And then we'd say like negative 3 is like here, and that derivative is 0. Right, and then usually for f prime, I put endpoint to indicate that this is an endpoint, and same over here. This at 3, it is an endpoint. So this is either going to be a max or a min, depending what happens with the derivative. Okay, so now we have our intervals, and we want to plug a test point in. So again, you can write it with the interval notation. We have negative 10 to negative 3, and we have negative 3 to 2, and then we have 2 to 3. We have those 3 intervals. We have this little interval at the end. My endpoint. And then you can put, we have our test point in each interval. And then we are interested in what f prime and f. So you can either write it this way or both. So for our test point, we pick a number that is in that interval. So some number between negative 10 and negative 3, doesn't matter, let's just do negative 5. And we plug it into the derivative. That's the key thing. We're trying to find the sign of the derivative. So we're going to find f prime of 5. So let me write the derivative down here. Now you can use this one, you can use your factored one. If you're not good at factoring, then stick with the original so that if you factored wrong, you're not going to get all of this wrong. But what we're gonna do is we're gonna plug -5 into this function. And we're gonna figure out what the sign is. And just use your calculator to find all these. All right, so I do this positive 84. So it's a positive, so I put plus in the F prime slot, and that means F is increasing in this time. Okay, then I need something between -3 and 2. So again, the easiest X value is 0 if it falls in there. I'm plugging it into my derivative again. And if I simplify this, I'm going to get a -36. So this, again, my test point was 0. So I got a negative, so that means it's decreasing. Okay, and so if I'm increasing and then decreasing, that means this is a max. And so then from -3 to 2, we did that. We need 2 to 3, so we pick something in there. So like 2.5. We could technically do 3 because it's an endpoint and not where the derivative is equal to 0. It won't matter. Okay, so I'm plugging it into this 2.5 squared. So that gives me 16.5, which is a positive. Okay, so positive. That means it's positive here. So my original function is increasing. So again, with this, you can see, okay, it's decreasing and then increasing. So this is a min. And then we also have to classify our endpoints. So at -10, my function, it has an endpoint and then it's increasing. And so what that means is at -10, this is going to be the lowest point because it's increasing, and this endpoint would therefore be a min because it's the lowest point. And at this endpoint, well, we're going up and then we're stopping here at x equals 3. And since we're going up to that point, this endpoint would be a max. Move this over a little bit. Okay, so it'd be going up until we get to -3 and then we'd stop. So this endpoint would be a max at 3. So if we then have to list them, and we're probably going to give both the X and the Y values. If they just said where, you would give the X values. So you would say, okay, I have a min at X equals 10 and X equals 2. Or -10. And on my thing, I have a max at X equals -3 and X equals 3. Now, so they just say Extrema, we also want to figure out the points, the Y values. So we plug that in to get the Y values to the original function because we want the Y value. We're going to write that down, 2x cubed plus 3x squared plus 2. Just make sure that's right. Okay, so to find, we would have to find the Y value at each of these points. We'd have to find f of 2, f of -10, f of -3, and f of 3. And one way to make this easiest is just to use your calculator and do the table. So what we would do is we would type in that function here. So we would do 2x cubed plus 3x squared minus 36x plus 2. Okay, we're putting the original function in, and then I would just go to second table. And if you don't have it, so you could see it, like you can go to second table set and put like where your table starts. So I want it to start at -10 and go up by 1, or you can also go to independent and then change it to ask. So you can just type them in and then second table. So I can see, okay, at -10, my value is -1338. Okay, at 2, I'm going to go to x equals 2. It's -42. At x equals -3, it's 83. And at x equals 3, it's -25. Okay, and again, this is a min, this is a min, this is a max, and this is a max. And even though it's -25, it's a max because it's just a relative max. And if they asked you for like the absolute extrema, the absolute min would be at -10, -1338, because this is the lowest value on that graph. And the absolute max would be, the highest one is 83 for the y value, would be -383. Okay, so that's how you do finding the max or min when you have endpoints on an interval.